let's see. We need to go over uniform distribution as normal distribution. Now, what is this chapter going to cover? Basically, it's going to cover a different way of finding probability. Chapter 6 is going to show you a different way, different method of finding probability. It's going to be showing you more graphically. And it's also going to be using z-scores in the future, or when we start off. That's chapter 6. I think we're doing 6.2, 6.3, and 6.5 or something like that. I can't remember. What does it say, chapter 6?
6.2, 3, and 4, and 5.
Okay, we probably won't skip 4. And also something else that we're going to do, we're going to talk about 2 types of distribution. One is going to be uniform, which basically is something, you know, out of 10 questions I give you, one of them is going to be uniform. And the rest is going to be normal. Okay, so something else I want you to remember about chapter 6 is when you see 4, when you see a number with 4 decimal places, that's going to be an area, a percentage, or a probability. They're the same thing. In this chapter, if the question says something about an area, if it says something about a percentage, or if it says something about a probability, those 3 things are the same. Okay. 2 decimal places is going to be a z-score. Now, the reason I talk about that now is because in the problems that we're going to be doing in class and problems you're going to be doing outside of class, whether it be homework or tests, it may say that the area is 0.4057. And if you see 0.4057, I want you to automatically know that that is an area or a percentage or a probability, but it's not a what? Z-score, because sometimes one of the biggest problems y'all have, students have in this section, is y'all flip-flop them. You go look up 0.40 as a z-score, and then you'll get it all wrong. It's not a z-score. 0.4057 would be a area, percentage, probability of those 4 decimal places. Usually when you get a question and you're given 2, that means you're given 2 decimal places, blah, 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 2.62. 2.62, you automatically should know it's a z-score. If you see 0.4057, 4057, that is 4 digits, that is a percentage. It should be automatic. Now, what do the two types of distribution look like? Uniform, there's only one thing that is uniform in our universe. What is that? Who said that? How did you know that? Not many people know that. Not many people think like that. You're thinking in the like fourth dimension or something. Not many people, let's do it. Not many people realize that. But if you think about it, what is the only thing that we cannot control? Not even the CIA can control it. Not even the NSA can control it. Nobody can control time. So that's why it's uniform. Okay? Uniform is written like this and is shown like that. Let's say that I usually end my class between I don't know what time class is. I'm going to say it ends at 2:30. I don't know what time it ends. But let's say I end it between 2:40 or 2:15 and 2:30. In other words, 90% of the time, I'm going to end my class at, or most of the time I end my class somewhere between 2:15 and 2:30. And based on that information, I want to know what is the probability of my class ending at 2:25. Okay? I want to know what is the probability of my class ending at 2:25. Well, the first thing you got to do is find the height and the width of this rectangle. You already know the area. What is the area? 1. So this probability. Probabilities go up to what? 1. Okay, so which one can we find without doing any calculation? Well, the width. What's that width? 15. So I'll put that in red because we know that between here, why do I have a red eraser? They should not even have different color erasers. Anyway, between 2:15 and 2:30 is 15. So we know that this distance right here, between here and here, is 15. Everybody with me? Okay, we know that area is equal to width times height, or base times height, or whatever you want to call it. And we know that the area is 1. What is my base? So what is my height? 1/15. So height is equal to 1/15. Okay, so everybody, that's part 1. With these type questions, there's 2 parts. First, you got to find the height. You got to find the height of the rectangle. Well, why did we have to find the width? The width is going to be what? Given in the question. It's going to be given. And then you got to find what is the probability that he will stop his class at 2:25, or his class will go over 2:25. Well, let's draw this is part 2. That's part 1. This is part 2. I have my new box, and I know that this is 1.00, but I know that this height is 1/15, and this is 15 down here. Okay. Now, the question is, 225 would be right about where? 225 would be right about here. And we'll say 225. Right there. Okay? And we want to know what is the probability of going over 225. Usually most of your wanted areas are going to be shaded like that. So, all we have to do is multiply this distance times this. Well, what is this distance? Huh? 5. Good. Pretty simple. That distance right there is 5 from here to here. If you don't believe me, take 230 minus 225, and what do you get? 5 minutes. So now we take area of the purple area is equal to 5 times 1 over 15. Area is equal to 5 over 15, which is what? 1/3, right? Which is 0.333, repeating. So what is the probability of my class going past 225? 33%. There's a 33% chance that my class will go based on the previous data, 215 to 230. So, first thing you do when you're given one of these problems, because you're going to have a couple of them on the test. First thing you do is draw a graph, draw a picture using the uniform distribution, which is a rectangle. 2, find the height. Based on what? That the area is equal to 1.000, and to find the base, that's going to be your highest minus your what? Lowest. Your highest minus the what? Lowest. And that's your 15. And then 3, go to part 2 and find the new base. And in this case, what was the new base? 5. And then you multiply that by your 1/15, and you get your 33%, 33.3% to be exact. Okay. So on chapter 6 test, if I give you 20 questions, 10 of them are going to be give me questions, and 1 or 2 of them are going to be like this. So let's do one. Let me just go to the homework. No coughing in class. I have to keep telling y'all that. All right, where's my uniform distribution? Okay, so they didn't give us any uniform distributions in the homework. Let's see. That's 6.2. Yeah, 6.2, that's right. Okay, maybe I missed something. Okay, we'll just go to the handy dandy study plan and find one. No, there is no study plan for 6.1, sorry. Oh yeah, 6.2 study plan. Should be the first question. There we go. I'm so good. All right.
Have a new message on Facebook.
Go ahead and write that one down. Vanna, blow it up for him. The waiting times between subway departure schedule and the arrival of a passenger are uniformly, ding, 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 distributed between 0 and 7 minutes. Find the probability that you're going to wait more than 2.25 minutes, 2.25 minutes. All right, do it. If you can't do it, then that means you're what? Well, for those are a failure. I like the word failure because it makes you more discouraged if I call you a failure. Right, Vanna? What do you need a calculator for? Such a disappointment. Such a failure. I just don't know how I'm going to make it. All right, Vanna, bring it down. So, I'm going to divide this into two sides, part 1 and part 2. Part 1, and we got a base of what? 0 to 7 is what? 7. So, the area 1.000 is equal to 7 times height. Divide by 7, divide by 7. So 1 over 7 is equal to the height. Everybody with me? So now we've got a (1/7) is the height, and we don't even want to write down anything else because we've got from 0 to what? 7. So 0. There's 0 right there. 1, 2, 3, 4, 5, 6, 7. Okay? And they want to know what the probability of going 2.25. 2.25. Well, 2.25, there's 1, there's 2. What is 0.25? Well, 15% is, or 15 minutes is a quarter of an hour, right? So 225, what would that be? Well, you could think of it as this. 15. I'm not going to. I'm thinking different. I'm trying to think this out because I want to try to do it without a calculator. X. Okay, you could do 25. I'm drawing a blank. 15 is to 60 as X, or is 25 is to X. That's not right. That wouldn't be right.
25 is 100.
Yes, that would be right. But no, that wouldn't be, no, there wouldn't be any X.
Why do you need an X?
Because I want to do it without a calculator. I want to convert this because 25 minutes, we could do it like this. This is what we could do. We could say 10 minutes is equal to 1/6 of a hour, right? That's correct. 10 minutes is equal to 1/6. We know that we know we got 225, so 20, they've got the 2 10s right there, so that would be 20 minutes is equal to what? 2/6, right? So we got 20 minutes is equal to 2/6, but we still got half of 1/6 multiplied by 1/2 would be 1/12. So we got to add 1/12 to 2/6. 2/6 plus 1/12, and that'll be a 12th here, and that'll be 5/12. There's our number right there. So somebody take 5 divided by 12 in your calculator and see what you come up with. See if you don't come up with 2.25. Yes, no, maybe.
0.41666.
I got it wrong.
Why can't you just put a 4? Why can't you just put a 4 for 0.25?
Because because we're not talking about 100 minutes. We're talking about 60. You could do this. You could do 25 is to 60 as X, or 25 is to 100, like you said a while ago. It's just backwards. I'm just trying to figure out a way to do it without using a calculator.
Like, is that saying 2 minutes and 25 seconds, or is it saying 2 minutes and a fourth of another minute?
It's saying 2.25 minutes. So that means basically 15 minutes, but 225 being 25 minutes. I think it is. It can be,
No, but there's only 7 minutes, so it can't be 25 minutes.
no, it's talking about part of a minute.
Yeah,
It's
so
talking about,
it'd be a fourth of a minute,
well,
which is 15 seconds.
I would think it would be 15. That's what I was thinking it was, but when you look at it, it could be taken as 25 hundredths of a minute. So I don't know if they're wanting us to think of it like that, or they're wanting us to think of 25. I would say 25 hundredths, which would be a quarter. We could do it. Let's just assume that it's saying a quarter, okay? Let's just assume that. Because easily you could say somebody could say 2.25 25 hundredths or 25 over 60. So, you know, it's kind of misleading there. So we're going to assume it's a quarter right here. So 2 1/4 minutes. I'm just going all over the place today. There. So 2 1/4 minutes. Right there. So they want to know what is the probability of going over 2 1/4. Well, we know that 2 1/4 away from 7, let's do that. 7 minus 2 1/4, well, we change this into what? 6 4/4 minus 2 1/4, and that gives us 4 3/4. 3/4 is right there. So this is 4 3/4. And now we take 4 3/4 and multiply it by 1/7. 4 3/4 multiplied by 1/7. Change this right here into 19 over 4. And that would be 19 over 4 multiplied by 1/7. Which would be 19 over 28. Okay, let's think a minute. Well, 15 over 30, what's 15 over 30? By 50%. So this one right here, what's 19 times 2? 19 times 2 is 36, isn't it? Or 28. What is 19 times 2? 38. So you're probably talking about around 50%. What does it come out to be? 0.67. Check this out. If you take 1 off of here, that'd be 18 over 28. And 18 over 28, let's see if we could simplify that. That's 18, that'd be 9 over what? 14. 9 over 14 you could take down, you could probably go down, you're getting 0.67. Is that what you got? Yeah, it can be taken down to 2/3 if you think about it. I'm trying to think how to get there. About 20 over 28. That'd be 10 over 14, which would be 5 over 7. Still not getting here, but anyway, come out to be 0.67. So that's 67 what? 6700, which is 67%. So you have a 67% chance of waiting more than what? 2 1/4 minutes. Okay? 0.68. So 2 parts. You got 2 parts. It says round to 3 decimal places. So what is it? And we got it right. We feel good about ourselves. And let's do a nerd. Just right quick. If the computer ever works. It's still calculating how to get to the next problem. Waiting time between subway departure, schedule, arrival, blah, 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 between 0 and 6 minutes. Find the probability that a random is 0.75 minutes. So that's 3/4 of a minute. Waiting time less than 3/4 of a minute. Think that's going to be high or low? It's probably going to be a low. Why? Think about it. Let's say you're going through New York and you're going to the subway and you've got to be at the subway station. You've got to be on there at 8 minutes. Let's see, 3 o'clock. And it's right at 3 o'clock. What is the percentage that you're going to have to wait 45 seconds for that train? I would say it's going to be very low. Why? When does anything run on time? Never. You're so smart. Or you quit, one of the two. No, you didn't. All right. So we got a base of what? 6. So we know, because we're so smart, that the height is equal to 1 over what? 6. We got 3/4 right here. So 1, 2, 3, 4, 5, 6. 3/4 is right here. Three-quarters of a minute. So our area of this shaded region is going to be 3/4 times what? 1/6, Hubert. That's right, class. Base times height. And that's equal to 3 over, dang old, that 3 cancels with that dang old 2 times 1/8. And what does 1/8 come out to be? Point what? I'm sorry, what? 125? So you got a 12.5% chance of that train getting there within 45 seconds. I wouldn't bet on it. But like I said, when does anything, exactly my point, whenever you go to something you dread, you ever been to a program or something you really didn't want to go to? Does it start on time? Heck no. It's going to start 20 minutes after when it's supposed to start on time, if you're really dreading it. Dang old Murphy's Law. All right, so at least you can do 2 problems on the test, right? Plus the 10 I give you, or the 10 or 12 I give you. So everybody should be able to make a what? A 50 on this test. Everybody. All right, so let's move on to one that's not. Look at there. That one's not uniform. What is that? Normal. Normal distribution. So let's talk about normal distribution here for a second. Do you remember me telling you a long time ago to start drawing these things like this and telling you to put the mean and standard deviation and 2 standard deviations to the right? You remember me telling you that?
Yeah.
Now is when we're going to be using it. And now you should be able to draw it without any problem. So if I give you a mean equal to 4 and a standard deviation equal to 2, you'll go 4, 6, 8, what's 2? 0. And you'll be able to, now that's what you're going to be doing in 6.3. All right? I mean, 6.2, the good thing is, this is 6.3. Let me write 6.3 right here. In 6.2, the mean is going to be equal to 0, and the standard deviation is going to be equal to 1. Why? Because in 6.2, everything is going to be based on z-score. Okay? And that's basically two standard deviations, or two z-scores to the what, right? And two z-scores to the left. So, in 6.1, all of your curves are going to look like this. Okay? So, make sure that when you are not doing a uniform distribution in 6.2, you might, I tell students this, get you a blank sheet of paper and divide it into, this is what I tell students to do. Get you a blank sheet of paper, divide it into 6 or 8. I tell students 6. And then draw you a curve in each one of these and label it 0, 1, 2, -1, -2. And do that 6 times, and then what? Run copies. Why? Because every single problem you do in this chapter, you're going to have to draw what? You're going to have to draw a picture. And guess what y'all are going to get tired of doing? Drawing the same thing over and over. So what I would do is take a sheet of notebook paper, put 6 of these on it, label it 0, -1, -2, 1 and 2, and then run about 10 copies.
So the numbers will never change?
Not in 6.2, it will not. 6.3 it will. And then I tell students, just don't draw the numbers. Just run the copies. Okay? So, as for all of you that don't mind the, what's the word? Work, you know, because that's the real tedious work here. Take you all of what, 15 minutes to do that? Some of y'all might not do it because it's too much work. Anyway, 0, -1, -2, 1, and 2. And make sure you can plot. If I tell you to plot 1.15, what is that? Well, how many place values? 2, what is that? That's a z-score. Then you go, okay, 1.12. Where is 1.15? 1.15. 1.15 be somewhere right here. Make sure you can plot. And what does it mean? Well, you don't know what it means because there's 2. How many sides are there to every coin? To every sword. To every story. All right? Remember that. It's going to help you in the future. This is more than. This is what? Okay, let's write that down. This is less than. That's the left side. And another color. More than is the right hand side. In other words, you could greater. What about the other side? Up to. Less than, up to, that you get the point. All right. In other words, they tell you find the area of blah 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 less than 1.15. Then you know you're going to find the left-hand side area. Now remember, when you're dealing with areas, if I tell you to find this area right here, if I tell you to find that area, You're going to find that area, but there's also another what? Another area over here called the what? COMP, the complement. Okay, which is the right-hand side. If I ask you to find this area, then there's another side. And that other side is the complement, which would be the less than, which would be this area. So sometimes the question will ask you to find this side. Sometimes the question will ask you to find this side. Now, if they asked you to find the right-hand side, why is that a problem? Well, I'm going to show you in just a minute, but I need you to all write this down. Right-hand side is equal to 1 minus the left-hand side. Write that down. Very important. How many times have I drawn this picture in the last 5 minutes? How many times are y'all going to draw it in the next 5 days? Probably 100. So you better do the copies. 0, 1, 2, -1, -2. Let's say that you go in your homework and you say, the homework says, find the area greater than 0.56. So they're asking you for that area right there. Well, that is the right-hand side. Greater than 0.56. And the greater than is the right-hand side. And the right-hand side is equal to 1 minus the left-hand side. Now, why is that? That is because of table A2. Now, in your book, if you've got a book, go ahead and get it out. Somewhere in your book, there is a table A2. If you don't have it, you can print one out. How do you print it out? Well, you got to go to Google and you type in, what edition are we in with Triola? What edition? Anybody know? Okay. Y'all all don't speak at one time. Triola.
12.
Huh? 12th edition, A2 table. That's all you type in. Everybody see that? Triola 12th edition, A2 table. It's a miracle. That took about 5 seconds. No sneezing, please. All right. Oops, I don't want to hit that. Okay. So let's move until you're looking for z-scores. So, how do you turn this stupid thing? Right here. Yeah. There it is. You got 2 pages. The negative z-scores and the what? Positive. Now, which one are we looking for on our problem? Positive, because it's to the right of the 0, correct? So, I want everybody to read these words right here. If I can do it right. There we go. Cumulative area from the what? Left. So that means that whenever you look up, whether it's the positive z-scores or the negative z-scores, what does it say there? From the left. It's only going to give you the area to the what of the number? To the left. What happens if you want to find the right-hand side? Well, you have to take 1 minus the left-hand side. The left-hand side is what the table gives you. See what I'm saying? You don't have a table that gives you the right-hand side. Okay? Unless you look up the opposite z-score. And then you could cheat doing that, but we don't teach people to do that. Okay? So, in our problem that we're doing, we got 0.56. What is 0.56? Well, it's 2 decimal places, Hubert, so therefore it's a what? It's a z-score. So you go to your handy-dandy table and you look for it and you look for 0.56. Well, what is 0.56? That's 50 cents, and what? 6 pennies. So you look up 50 cent. We got to go to the positive, sorry. 50 cent, let's see, there's 50 cent right here. And then how many pennies? 0, 1, 2, 3, 4, 5, 6. So the area to the left of 0.56 is 0.71 what? 0.7123. So 0.7123 is right here. That's what the table gave us. And the table gives us everything to the what? To the left. But our question,
So you just
good job.
that makes sense.
Now it makes sense. 1 minus 0.7123 is equal to, well, let me ask you a question. What's $1 minus 71 cents? 29 cent Hubert. That's right, class. So, 0.2877. 0.2877. Do you need a calculator for this? No, you do not. So don't be using one. You don't need a calculator to take 71 cents from $1. You should be able to do that.
So what do we have to do with this other way around if they ask for the left-hand side?
You just write down what's in the table. The reason I show this first is because this is the one that gives y'all the problems. If the table asks, if the question asks for the left-hand side, y'all just write down what's in the table. Now, there's also a function on your calculator that will help you check and do it in a faster way, and I'll show you how to do that. Not right now, because I want you to crawl before you can what? Walk. All right, let's do an error. Let's pull one out of the homework this time. So y'all can feel better about yourself. All right, let's do this one. Well, I want one on the left-hand side now. We've done one on the right-hand side. Okay, there's one. All right, this one says blah, 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 blah. They want to know the shaded region. What is this region that's green? All right, draw you a picture. I want you to plot the 0.55 because it's important that you know where the numbers are. And I'll show you why in just a second. So draw a picture with 0.55 with in relation to your 0, 1, 2, and -1 and 2. I want you to be able to draw it in proportion, and I want you to shade it. Now, there's two things I want you to ask yourself before you look at the table based on your drawing. This is going to really come in handy when you're in 6.3 and 6.5 and all that stuff. Here's my drawing. Somewhere right here. I'm going to do it in blue. All right, now there's two things I want you to ask yourself at this point. One, is z-score positive or negative? And don't answer that. Two, what is percentage between? Now, the reason I ask these two questions, or I tell students to ask these two questions, is because you would be surprised on how many people look up -0.55 and then write down that number and then put that, which is going to be less than half, and then they'll put that as the answer. When they're looking at a picture that shows, one, what is the z-score? What is the z-score? It's positive. This side here is what? It's positive. All right? So that way, you don't look at the negative z-score table. The second thing is, remember when I told you this was an empty gas tank? And this one is half full, and this is full? What's the second thing going to tell you that your percentage is going to be over? It's going to be between half full and what? 3/4 full. It's going to be between 0.5 and 0.75. So therefore, there's two little things there that will help you keep from getting the wrong answer. So we looked up in our handy dandy positive table, and we look up 0.5 what? 55. So that's 50 cents and 5 pennies. 1, 0, 1, 2, 3, 4, 5. 0.7088. And 0.7088 is our area to the left of that number. 71%. And 71% falls between 50% and what? 75%. See what I'm saying? So it's always nice to ask those two questions. All right, let's try nerdy. Where is our dang old done? Go away. All right. Nope, not yet. All right, try that. Draw a picture first. All right, question. The first question, is my z-score positive or negative?
Negative.
It's negative, so that means I'm going to look on the negative z-score list. 2, what is my area going to be to the left-hand side of this guy? Well, this is 25%. So that means that this is going to be right here, this little area right here is going to be less than what? Area to the left is going to be less than 25%. Therefore, the area to the right is going to be what? Greater than 70 what? More than 75%. Common what? Common sense. If this is 25%, close to it, then that means that this is 25% and this is 75%. We know that this is passing this -1 here, so this is less than 25%, so this is going to be more than 75%. So, let's take our handy dandy table. We got to look it up. I know, this work. There it is. So we go to our handy dandy negative table and look up, I done forgot z-score, 1.16. So that's $1.10 and 6 pennies. So we're looking for 1.1 and 6 pennies. 0, 1, 2, 3, 4, 5, 6. 0.1230. 0.1230. Now, what did I tell you when you're trying to find the left-hand side and the right-hand side? The left-hand side, or 1 minus, right-hand side, sorry. Right-hand side is equal to 1 minus the what? So that's going to be 1 minus 0.1230, which is going to be well, think about it. What is $1 minus 12 cents? 88 cents? So that's going to be 8770. So your area to the right is 0.8770. And we feel good about ourselves. Oh my God. What's the problem? They're not giving us a z-score here. What are they giving us?
The area.
They gave us an area. How do we know that? It's 4 digits. And they tell you. Find the indicated z-score. So there's 2 types of questions in this section. Well, 3 types. In 6.2, there's 3 types of questions. 1 is uniform distribution, and 2, normal distribution given a z-score. And if you're given a z-score, you find the what? Find the area. The third question is normal. You're given the what? Area, and you find the what? And you find the z-score. And you know that because it says it right here, and you know that 4 digits is an area. So we take our handy dandy picture and draw it. Now, where is 0.85? 85 is above what percent? 75%, right? So right here, 75%. So technically, this is 50%, and this is like what 34%. So that's 84%. 84% is right in here. So 85% is going to be right somewhere in here. And I'm going to draw, and this area right here is 0.8531. Okay, so 2 things. 1, is our z-score going to be positive or negative? Positive, because it's on the right side of what? 0, Hubert. So it's going to be positive. And is our area greater than 50%? Yes. So it's going to be, well, technically, it's going to be more than 75%. Because this right here is 50, and this right here is 34. So that'd be 84. So yeah, it's going to be more than 75%. So you know what it looks like. Our z-score is going to represent that too. You got to ask yourself these common sense questions, because, like I say, I'll get somebody and they'll read negative blah blah, or they'll read 0.8541, and they'll give me the negative z-score. It's not right. So try to, So we know it's going to be positive, so we look under this guy right here. So we go to our handy dandy positive z-score page, and we look for an area of 0.8531. 0.8531. Okay, I see some 8s right in here, so I'm going to start looking in here. 0.8531. There we go. There it is. $1 plus 0, 1, 2, 3, 4, 5 cents is 1 point what? 1.05. And look at there, I had it right past 1. 1.05.
But it necessitates what they're doing in the middle.
1.05. That's like a nickel. You're thinking of 1.5, which is. All right, one more. Before I show you the next one, I want to ask you a question. Let's say we're in Anderson, and Anderson is right here. And there's Spartanburg. And in the middle is Greenville. And let's say that between Anderson and Greenville is 30 miles. And between Anderson and Spartanburg is, let's just say, 70 miles. So if I know Anderson to Spartanburg is 70 miles, and I know Anderson to Greenville is 30 miles, then what can I do to find out how far it is from Greenville to Spartanburg? Subtract the smallest one from the what? And that'd be 40 miles. Okay? And people, we do this every day. All right? So, let me get rid of this. And do this one. No. Let's see. No. I'm trying to find a certain problem that you're going to run into while you're doing homework. There it is. All right. It says, assume blah, 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 bone density test. These test scores are distributed with a mean of 0 and standard deviation of 1. Find the probability that a given z-score is between negative 2.16 and 3.67. So draw a picture first. No coughing in class. So negative 2.16, that's right in here, isn't it? Okay, I'm going to do that in blue. Since it's red, I'm going to do it. Since it's negative, I'm going to do it in red. And the area the table is going to give us is right there. The other one's 3 point what? 3.67. I'll do it in blue. And that area is right there. So what if I want to find the area between negative 2.61 and 3.67? Greenville, Spartanburg. Subtract the big area, the little area from the what? Big area. Subtract the red area from the what? Blue area. So, we take our handy dandy, let's see, let's find our big area, 3.67. The area for 3.67 is going to be in blue. .67 is what? 0.9999. So we put that down. And now we got to find the area for the red section. which is 2 point what? 2.61. There's 2.601 is 0.0045. And that's 2.61. Subtract those. 4, 5, 9, 9. So the area between there is basically, and I'll shade that, shade it in green. You're finding this area right here between the two. And that area is 0.9954. Now, there is a way that you can do this on your calculator. Pull up your handy dandy calculator. I think it's second bars. Yeah. Normal PDF. Normal PDF. And what was that last number? I read from left to right, so I'm going to do it this way, left to right. Negative what? 2.61? Comma. And what? 3.67, close parentheses, and enter. Okay, I think I did something wrong.
I think it's
CDF. I thought I hit CD. I'm sorry. Math, or second function, bars. Let's try that one. Negative 2.61,
yeah.
comma, 3.67, close parentheses. There it is, 0.99554. 0.9954. Now, if you wanted to find the z-score for the area, you hit inverse norm. So the problem we did a while ago, somebody give me that area that we had. Second bars, inverse norm, and somebody give me the area that was given. Type in the area and hit enter. It's 1.16. So that's the way you do it with the calculator. But like I say, it's kind of nice to know what you're doing with the calculator before you do it with the calculator. Okay? Capiche? So let's do another. Let's do one more and then we move on to 6.3 and I'll show you the difference between the two sections. Alright, take a look at this one. Now the difference in this one, no, I want another between. They're not going to give me another one. I don't want that one either. I'll just make one up. Let's just make one up because I want one that I'm going to give you on a test. Alright. I want you to tell me the area between, and I'll put the first one, I'll put it in or red since I'm going to make it negative. And I want you to do it by hand and then we'll check it with the calculator. Negative 0.67 and positive 1.5. So I want to know this area right here. and I'll color it magenta. Now, common sense wise, what is this area right here between these two marks right here? 34, right? And I think this is 12 or something like 12% right here. Half of 12 is what? 6. So that's 34 plus 6 is what? 40. And then half of 34 is 15 plus, so, well, 17. What did I say this was? 34 plus 6 is 40 plus 17. So we know it's going to be around what? 0.57. Common sense wise. So let's see what it comes out to be. All right. Somebody look in your table and give me the area in 4 digits of 1.5. Area of 1.5. Somebody give that to me. Oh, y'all have table? Y'all suck. All right, table. 1.5. Let's go down. 1.5 is 0.9332. 0.9332. Now let's go find 0.67. Negative 0.67 is going to be 60 cents plus 7 pennies. 6, 0, 1, 2, 3, 4, 5, 6, 7. 0.2514. Point 2514, 8, 1, 13 minus 5 is 8. Y'all help me out. And 8 minus 2 is 6. Somebody help me out here. I get 0.6818, and that's magenta, so I wrote that down. 0.6818. And 0.6818 is that area right there. So let's check it on the handy dandy calculator. And that's the good thing about the calculator. You don't have to subtract with the calculator. You just punch in from negative 0.67 to 1.5. So take our handy dandy calculator. Second, bars, normal CDF, negative 0.67, comma, 1.5, close parentheses, enter. It's a miracle. 0.6818. 0.6818. Well, heck, that's easy, isn't it? Yes, Hubert. Thank you, class, for the interaction. And what's hard about it? Well, in 6.3, they add a little twist to it. Let's look at 6.3, and I'll show you what the twist is. I'm not even going to show you the text in 6.3 because there's no use in it, because I'm going to show you what you're going to do. All right? Look at this question and tell me what the difference is. The shading is a different color green. No, that's not the difference. Huh? Well, what do they give you? The mean and standard deviation has changed. Now it's 115. But it's not that difficult because we remember our formula for z-scores. What is our formula for z-scores? I thought it was x minus x bar over the standard deviation. That's what I thought it was. Y'all tell me if I'm wrong. Z-score is equal to x minus x bar over the standard deviation. I'm also going to give you another formula for 6.3. And basically, if you solve for x here, you get x is equal to Oz plus mu, which is how you get x. This is later on in 6.3. This is first part of 6.3. So, let's look at our problem.
So we're not drawing the bell curve.
Yeah, you're going to draw a bell curve. Yes. So let's take our draw it, and we're going to draw the bell curve. And our 100, and that's 115, and 130, and 85, and 70. Everybody with me? See, I'm not even looking at this right now. Okay? I'm just drawing my bell curve based on what two numbers? The mean and standard deviation. Remember me telling you that whenever you see the mean and standard deviation, chances are you're going to draw the bell curve. This is why. Now, they're supposed to put, that right there is incorrect. That's supposed to be 0.6500. Why? Because it's an area. Exactly. It's an area. And I don't want you to get confused. Now, that's why students get confused. Why? Because they think it's a what? They think it's a z-score. All right? So, don't do that.
Basically, if it's inside of the thing,
It's inside. So, we've got point now. What can you do with that? Well, you know that this is about what? So, you know that 65 is going to be somewhere what? In here. So, I'm going to take my handy dandy green marker, since that's greenish color, and I'm going to put, and I'm going to draw hash marks. So we know we're looking for a score between 100 and what? 115. So, what do we do first, Hubert? Well, we got to find this z-score first. The only thing they give us is a what? Area. And what did I tell you in the first section? They're going to give you an area, or they're going to give you a what? A z-score. Here they're giving us an area. So that means we got to find the what? Z-score. So take your handy dandy. What kind? Okay, tell me. What kind of z-score is it going to be? Positive. So you can pull up your positive z-score table. And the reason you know it's positive is because it's past 0. And we're going to look up 0.6500. 0.6500. Here we go. Somewhere in here, somewhere in here, somewhere in here. We're looking at $65. $65. Here we go. Boop. $65 is what we're looking for because we like money and we know $65. We know what $65 is close to. Is $65 closer to $64.80? Or is it close to $65.17? It only takes you a split second to know which one it's closer to. It's closest to this guy right here, which is 0.39. So there's our z-score. So we take it over to our handy-dandy problem. Get out of this. How do I get out of this? There we go. So we know that our z-score is 0.39. Okay, now we got something to go by. Now, I gave you two formulas a while ago. One formula, I said z is equal to x minus x bar over standard deviation. We don't need this because we've got our what? Z-score. So we don't need that, we need the other one. X is equal to Oz plus mu. Well, what do you think the O is equal to? Which is 15. And the Z, what do you think that is? 0.39. And then what is mu? 100. Somebody add that with your calculator. And yes, you need to calculate that.
It's
105.85. Does it fall between 100 and 115? And that's how.
Plug them into either one of those?
You're going to use one of those two or both. You're going to use both.
Like, couldn't you have plugged that problem into the other formula?
Which one?
Like the 15 and 129
Into which one?
into
This one?
X minus X bar over.
Well, you didn't know 0.39.
But you can put it as a Z.
Well, yeah, but then you have to solve for X, which you've already got that solved for X. I just, when I show people how to do this chapter, the first thing I do is give them these two formulas. Okay? The book doesn't give you this formula. They think that, okay, they'll plug it in and solve for X. Well, some people don't know to do that. Some people will plug them all in and they'll just sit there and look at this formula. They won't solve. They'll just sit there and look at it. Okay? So the Z-score is, of X is 105.85. It sounds 105.9. I got it right. All right, you try that one. Make sure you draw a picture. Yeah, excuse me. Okay, y'all done?
No.
All right. And 100, and 115, and 130, and 85, and 70. And they want the area between 80 and 105. So 80 will be somewhere right here.
Priority 1 message coming in on secured
And
channel.
105 will be somewhere right here. There's 80. There's 105. Now, in order to look up an area, we have to have what? Z-score. So Z-score for 80. I can't write it for some reason. Try this again. Z-score for 80 is going to be 80 minus 100 over 15. Now, did I say anything like, well, let's see, that's going to make negative, so I need to put the 100 first. Did I say anything like that? Then you don't need to be saying. That's when y'all start thinking. I got some students that'll put the 100 right here and say 100 minus 80, and then they'll wonder why they get the wrong answer. The formula is x minus what? Okay, it doesn't say, well, you figure out which way you need to make a positive number. It doesn't say anything like that. It says x minus x bar. There's x bar. There's the average. You put the average where it says put it. You don't start thinking. So the z-score for 80 is going to be equal to negative 20 over 5 over 15, which that is negative 10 or negative, well, negative 4 over 5, which if I wanted to change that into tenths, it'd be 8 tenths. 0.8, negative 0.8. Somebody check me.
No. It's negative 1.33333.
No, well, I just, look what I did here. 5 is going 3 times. There we go. Sorry. My bad. I can't add. Okay, what'd you come up with? Negative point what?
1.3333.
Okay, so there's our z-score for that side. Now what we're going to find? Z for 105. That's 105 minus 100 over 15. And that's equal to 5 over 15, which is equal to 1/3, which is equal to 0.33. So the z-score for the right side is 0.33. So now what do? Well, you take your handy dandy calculator and you type in whatever you type in, negative 1.333333, comma, 0.333333, comma, and what do you come up with?
0.5392.
0.53 what?
92.
And that is your area of that region right here. So it says, where's the answer? Oh, round 4 decimal places. 0.5392. We got it right. All right, try that one. Now, have you noticed something they haven't given you here? What haven't they given you? A little picture. Because they want you to what? Golly, takes a lot of work. I need to change back on the mean standard deviation a little bit. Between 90 and what? Negative 0.67. And 0.67. So somebody tell me what the area is between negative 0.67 and 0.67. 0.4946. Now, if you didn't use your calculator and go between negative 0.67 and 0.67, then you would have to use your table and find 0.67. 0.67, 0, 1, 2, 3, 4, 5, 6, 7 is 0.7486. Somebody write that down. 0.7486. And then negative 0.67. Zero, 1, 2, 3, 4, 5, 6, 7, 2514 minus 0.2514, and that'll give us a 2, a 7, 14 minus 5 is 9, and 6 minus 2 is 4, 0.494272 on the 46.
That's not what.
Did I not look it up right?
I don't know.
Oh, I bet I know. I rounded on both of those. So I need to do 0.66. Negative 0.66 is 0, 1, 2, 3, 4, 5, 6. 0.2546. And the other one is I'm looking for it. There it is. 0, 1, 2, 3, 4, 5, 6. 0.47. Can't read it. Point 4, 0, 1, 2, 3, 4, 5, 6. 0.7454. 0.7454. 4 minus 6. 14 minus 6 is 8. 0. 14 minus 5 is 9. And 7 be 4908. So you're coming up with two different answers, but they probably are assuming you're using the calculator. I don't know why they're coming up so different.
Well, they round there too.
Yeah. But still, I should be getting closer than these two. These two are way off. Okay. So I got 0.4946. .49. I'm gonna just say point 0.3. Let's see what their tolerance is. .4950. And what did we get? 4946. Oh, there it is. All right, they do. See here? See there? That is your calculator answer, and that's your table. So they did round to .67 on both. If you'll look at which one on the one I did by hand? Let's look. .4972. So they're doing it rounding .67. 4972. Hold on. There it is. .4972. So they are putting the calculator answer in there, and they're putting the table answer in there, plus or minus 1,000. Tens, 100,000, 10,000, to 1/10,000. So they're adding a grace to 1/10,000 to each answer. So this can be .4951 or .4949. This one can be .4971 or .4973. So they put that variance in there for you. Okay? Question. Everybody good on those two sections? All right, so what everybody needs to be working on now is 6.2 and 6.3 material. 6.2 and 6.3 homework, okay?